Welcome to this video on polar plots. Let's insert a polar coordinate system. Go to the Plots tab, Insert Plot, Polar Plot. A polar coordinate system is a two-dimensional coordinate system in which each point is determined by a distance from a reference point, called the pole, and an angle from a reference direction, the radial axis. The placeholder for the variable, which contains the angular axis, is placed below the plot. Normally we use theta as name for the angle. By default, theta is a range variable starting at 0 and finishing at 2 pi. The placeholder for the function is to the right of the plot. Let's here enter the simplest possible function, 1. And our plot will be the unit circle. To make it easier to see, let's increase the thickness of the circle. Now let's plot the constant function, 0.5. So add a trace, enter 0.5. The radial axis have changed, so let's change it back to start at 0, and we'll have a circle with a radius 0.5. Let's take another simple example. Insert a plot, theta along the angular axis, and also theta at the radial axis. We have a spiral. To see that the spiral is the correct plot, let's draw some circles. Pi divided by 2. It intersects the spiral here exactly at 90 degrees. So that's okay, as pi divided by 2 corresponds to 90 degrees. Let's take another one. It's easiest with Shift Enter to insert a new trace. We have intersection here at 180 degrees. So this seems to be correct. We can also plot points. Points must be entered as vectors of same length, with the angles in the first vector and the radii in the second. However, if you only want to plot a single point, the coordinates can be entered directly. To see the points, go to Symbol and select, for instance, a solid circle, and then to Line Style, click None, and we have our 3 points. Now let's introduce a negative radius. Let's change this to minus 0.8, and the point disappears. Let's allow negative radii. Change the 0 here to -1, and we have our point back. But the placement may seem a bit odd. So let's draw the 0 circle. So the -0.8 is the distance from the 0 circle to the point. With this understanding of negative radii, let's plot the sine function. In the interval from pi to 2 pi, sine is negative. So if we allow negative radii, we'll have this curve. To analyze the curve, it would be wise to draw the 0 circle and remember how negative values are plotted. In our final example, we'll take a look at the famous cardioid curve. In a special context, this curve is a pickup curve for a certain microphone. The mic is placed along the radial axis with its top at the center, front facing the right-hand side of the circle. The curve shows that the mic is most sensitive at 0 degrees, and the sensitivity gradually decreases from 0 to 180 degrees, where we have maximal rejection. At the sides of the mic, here at 90 degrees and 270 degrees, we have half the sensitivity. To see this, let's draw a circle. It intersects exactly at 90 degrees and 270 degrees. Thanks for watching.